The future of African military aviation may not be coming from Washington, Moscow, or Beijing. It may be rising from the heart of southern Africa. And if the claims surrounding Maxwell Chikumbutso are to be believed, the continent could soon witness a transformation that challenges the global balance of aerial warfare. Imagine a new generation of war helicopters engineered not just for combat, but for strategic dominance. Machines designed to operate in extreme heat, rugged terrain, dense forests, and vast desert landscapes. Aircraft built specifically for African conditions, not imported and modified as an afterthought. This is the bold vision associated with Maxwell Chikumbutso, a Zimbabwean inventor whose ambitious technological announcements have sparked both intrigue and controversy. For decades, African nations have relied heavily on foreign defense suppliers. From aging Soviet-era gunships to refurbished Western platforms, the continent's air forces have often operated equipment that was never designed with African battle environments in mind. Maintenance costs are high. Spare parts are difficult to source. Upgrades depend on geopolitical alliances. And strategic independence remains limited. Now, imagine breaking that cycle. The concept behind these revolutionary war helicopters centers on self-reliance, efficiency, and advanced integrated systems. The proposed designs emphasize lightweight composite structures to improve maneuverability while maintaining armor protection against ground fire. Advanced propulsion systems are said to offer improved fuel efficiency, allowing extended operational range across remote regions without constant refueling infrastructure. But the real disruption lies in autonomy and systems integration. Modern warfare is no longer just about firepower. It is about data dominance, battlefield awareness, real-time communication. The helicopters described in Chikumbutso's vision would incorporate AI-assisted targeting systems capable of identifying threats through advanced sensors, thermal imaging, and pattern recognition. This reduces pilot workload and increases response speed in high-risk engagements. Picture a scenario over a dense forest conflict zone. Traditional helicopters struggle with visibility and terrain mapping. A next-generation platform equipped with terrain-adaptive radar and AI-enhanced navigation could fly lower, quieter, and smarter, adjusting in real time to environmental variables. That shift alone would redefine tactical advantage. And then there's the matter of hybrid warfare. Africa's security challenges are diverse. Insurgencies, border disputes, anti-piracy operations, counter-terror missions, and peacekeeping deployments. A modern African-built helicopter platform would need to be modular, capable of rapid reconfiguration between troop transport, medical evacuation, reconnaissance, and heavy assault roles. One day it carries special forces into a high-altitude region. The next, it deploys surveillance drones mid-flight. The next, it supports disaster relief after flooding. Multi-mission flexibility becomes the cornerstone of cost efficiency. This vision also speaks to something deeper than military hardware. It represents technological sovereignty. Developing indigenous aerospace capability requires advanced materials science, avionics engineering, propulsion research, software development, cybersecurity integration, and precision manufacturing. It demands training a new generation of engineers, pilots, and defense analysts. The ripple effect could stimulate research universities, defense startups, and regional supply chains. But bold visions invite bold skepticism. Many observers question the feasibility of rapid aerospace advancement without transparent testing, independent verification, and international certification. Military aviation is one of the most complex engineering disciplines in existence. Designing a safe, combat-ready helicopter requires years of wind tunnel testing, flight simulations, stress analysis, and live-fire validation. Yet history shows that transformative breakthroughs often begin with audacious ambition. Nations that once depended entirely on imports eventually built their own defense industries. Turkey did it. South Korea did it. Brazil did it. Why not an African state? If even a fraction of the proposed capabilities materialize, extended flight range, AI-assisted targeting, hybrid electric propulsion, reduced radar signature, and modular payload architecture, the strategic implications would be significant. African air forces could negotiate from a position of strength. Regional coalitions could standardize locally built platforms. Maintenance ecosystems could develop domestically, reducing long-term costs and dependency. Defense spending could circulate within the continent instead of flowing outward. And consider the psychological dimension. Military strength is not solely measured in hardware. It is measured in confidence, deterrence, and perception. A domestically developed advanced helicopter program signals technological maturity. It tells the world that innovation is no longer geographically confined. Still, the ultimate test will not be in press conferences or conceptual renderings. It will be in flight performance, operational reliability, and battlefield survivability. Can these helicopters withstand harsh desert sand ingestion in turbine systems? Can their avionics survive electromagnetic interference? Can their AI systems operate securely against cyber intrusion? Can maintenance crews sustain them in remote bases without foreign contractors? Those questions define whether this vision becomes a milestone or a moment. If successful, the impact would extend beyond Zimbabwe. Defense collaboration across the African Union could evolve. Shared production lines, joint research labs, standardized pilot training programs, a continental aerospace network slowly taking shape. And imagine the first live demonstration. Rotors slicing through dry African air. A sleek, angular fuselage reflecting the sun. Advanced optics scanning the horizon. Engineers watching telemetry streams in real time. Military officials calculating operational metrics. Skeptics watching closely. The helicopter lifts. Stabilizes. Maneuvers sharply. Climbs. Executes a tight tactical turn. Deploys a simulated countermeasure flare. Lands with precision. Silence. Then realization. Because if Africa can design, test, and deploy its own next-generation war helicopters, the implications ripple far beyond defense. It signals entry into a higher tier of technological capability. It shifts narratives. It redefines expectations. But even as this possibility gains momentum, deeper strategic considerations emerge. Air power is evolving globally toward unmanned systems, drone swarms, and AI-driven coordination between aircraft. If Chikumbutso's vision includes integration with autonomous support drones, secure satellite communications, and digital battlefield networks, the transformation becomes even more profound. Picture coordinated operations where a manned helicopter serves as a command node, directing unmanned aerial vehicles across hundreds of kilometers. Data flows in real time. Threats are identified before they are visible to the human eye. Engagement decisions are supported by predictive analytics. That is not incremental improvement. That is doctrinal change. And yet, the path from vision to reality is narrow and demanding. Funding, regulatory oversight, international pressure, technical verification, and geopolitical dynamics will all influence the outcome. Defense innovation operates in a world of scrutiny and consequence. Still, something undeniable is happening. Across Africa, technological ambition is rising. From fintech revolutions to satellite launches, from renewable energy breakthroughs to digital infrastructure expansion, the continent is asserting itself in sectors once dominated elsewhere. Military aviation could be the next frontier. The question is no longer whether Africa deserves indigenous aerospace capability. The question is whether this moment, this bold declaration of revolutionary war helicopters, becomes the catalyst that accelerates a continent into a new era of strategic autonomy. Because if the rotors truly begin turning, if prototypes move beyond concept, if engineers convert ambition into airborne reality, and as those rotors cut through the air, it's not just about military might, it's about perception, signaling, and influence. Every flight, every demonstration, every successful maneuver sends a message. African innovation is no longer confined to ideas on paper. It can operate, dominate, and compete in real time. Neighboring nations will take notice. International observers will analyze patterns, and global defense industries will be forced to rethink assumptions about African capability. Training becomes a critical factor. A machine is only as effective as the people who operate it. Maxwell Chikumbutso's vision seems to include a holistic approach, not just building helicopters, but cultivating elite pilots, engineers, and maintenance crews capable of sustaining these platforms in challenging environments. Advanced simulators, AI-driven flight programs, and tactical exercises could give operators a mastery unmatched by legacy systems imported from abroad. The helicopter becomes not just a weapon, but a platform for a new class of African aerospace professionals. Logistics and sustainability will redefine strategic advantage. Traditional air forces are often hampered by dependency on foreign spare parts, long supply chains, and costly maintenance contracts. Locally engineered systems, paired with indigenous supply chains, could dramatically reduce downtime, operational costs, and reliance on international actors. In conflict scenarios, this self-reliance could prove decisive. A helicopter grounded for weeks waiting on parts from overseas can mean the difference between victory and loss. With domestic production, that gap shrinks. Then comes the integration with intelligence and surveillance networks. The modern battlefield is data-driven. Real-time communication between air assets, ground forces, and command centers creates an ecosystem where situational awareness defines success. Maxwell Chikumbutso's proposed platforms, equipped with next-generation sensors, encrypted communications, and AI-assisted targeting, could turn each helicopter into a force multiplier, collecting, processing, and disseminating battlefield intelligence faster than traditional channels allow. Imagine a combined operation over a contested border region. Reconnaissance drones feed data into a central AI system aboard a manned helicopter. Threats are detected before they can engage, routes are optimized in real time, and precision strikes are coordinated with minimal human delay. What used to require large numbers of personnel and aircraft could now be accomplished by fewer, smarter, and more capable assets. And the implications for peacekeeping and humanitarian missions are just as significant. Rapid deployment capabilities mean that disaster zones can be reached faster, medical supplies delivered where they're needed most, and civilians evacuated with efficiency previously thought impossible. A helicopter fleet designed for combat, yet adaptable for humanitarian use, strengthens both national defense and regional stability. International partnerships may follow. As African nations demonstrate technical competence, research collaborations with universities, aerospace firms, and tech innovators could expand. Knowledge transfer, joint ventures, and co-development agreements could emerge, reinforcing both economic and strategic benefits. African airspace could become not only a theater of defense, but a hub for technological growth, innovation, and continental pride. Yet, the challenge remains, turning vision into operational reality. Prototypes must withstand rigorous testing under extreme conditions: high temperatures, dust, humidity, unpredictable weather, and potential combat stress. Pilots must learn to trust AI systems without relinquishing ultimate control. Engineers must ensure that avionics and propulsion systems are resilient, redundant, and reliable. Every component, from rotor blades to software algorithms, must function seamlessly, or the entire platform's credibility is jeopardized. But history is on the side of bold innovators. Every major leap in aviation began with uncertainty, skepticism, and technical hurdles. From the Wright brothers to supersonic jets, from early drones to autonomous aircraft, audacity has always preceded transformation. Maxwell Chikumbutso's helicopters could follow that same trajectory, turning initial doubt into lasting achievement. As prototypes take shape, and as the first operational units are deployed, the narrative begins to shift. African nations could move from dependency to autonomy, from observers to innovators, from users to developers. The helicopter is more than metal and rotor. It is a symbol of ambition, capability, and a future that refuses to be dictated by external powers. Every flight, every test, every advancement carries with it a lesson. Technological sovereignty is achievable. Operational excellence is attainable. Strategic influence can be homegrown. And as these helicopters rise into the skies, the message becomes clear. African military aviation is entering a new era, and the world is watching. And as these helicopters rise, the eyes of the world will inevitably track them, not just for their mechanical ingenuity, but for what they represent, a bold assertion of African innovation in an arena long dominated by foreign powers. The aerodynamic lines, advanced rotor design, and signature stealth elements are more than engineering. They are statements. Every maneuver is calculated to demonstrate agility, endurance, and strategic versatility. Envision a fleet patrolling vast, border-straddling regions. Sensor arrays continuously scan for threats, feeding real-time intelligence into secure networks. AI-assisted navigation adjusts flight paths automatically, accounting for changing wind patterns, terrain challenges, and potential obstacles. Pilots operate less as sole decision-makers and more as commanders of an integrated system, directing drones, coordinating with ground units, and managing payloads with surgical precision. In operational terms, these helicopters redefine flexibility. One unit can switch from high-speed interdiction to reconnaissance missions within minutes. Another can transition from troop insertion to casualty evacuation seamlessly. Modular armament allows weapons to be reconfigured based on mission requirements, guided missiles, machine guns, or electronic warfare suites. In essence, each helicopter is a multipurpose tool capable of adapting to unpredictable scenarios without compromising performance. But it's not just about versatility. Survivability is central. Composite armor designed to deflect small arms fire, advanced countermeasure systems to evade missiles, and redundant flight control mechanisms ensure that, even under attack, these helicopters remain operational. Real-world scenarios over hostile terrain, where conventional platforms might falter, become achievable missions. The broader strategic picture is equally compelling. Regional coalitions could synchronize deployment of these platforms, creating a networked air defense system spanning multiple countries. Shared data protocols and cooperative training exercises allow a rapid response to emerging threats, insurgencies, or natural disasters. Africa's air power could evolve from fragmented capabilities into a coordinated, continent-wide strategic asset. And consider the cascading effect on technology ecosystems. Developing these helicopters demands cutting-edge avionics, AI software, propulsion systems, and materials engineering. Universities, research labs, and private tech firms could find new purpose, producing a generation of engineers, pilots, and technicians equipped to maintain, upgrade, and innovate beyond the initial designs. Knowledge becomes as critical a weapon as the helicopters themselves. Equally important is the psychological impact. Sovereign technological achievement sends a signal far beyond military circles. It communicates capability, independence, and ambition. Neighbors, allies, and even global powers are forced to acknowledge that African nations can develop, deploy, and maintain advanced military assets without relying on external suppliers. Confidence, deterrence, and influence all expand alongside the rotor blades cutting through the sky. Yet the road ahead is intricate. Flight testing in varied climates, electromagnetic interference trials, live-fire exercises, and AI systems stress testing all require meticulous planning. Each step must prove that these helicopters are not just conceptual marvels, but practical tools capable of operating under combat conditions. Failures are inevitable, but each failure informs refinement, bringing the fleet closer to operational readiness. And as prototypes mature into production-ready models, international attention intensifies. Defense analysts, military strategists, and geopolitical commentators will scrutinize every specification, every flight demo, and every statement from Chikumbutso's team. The global defense industry may respond with innovation, competition, or even collaboration, but the narrative has shifted. Africa is no longer merely a market, it is a creator. This evolution also has profound implications for future warfare doctrines. Autonomous drone integration, AI-assisted coordination, and networked battlefield communication suggest a hybrid model where manned and unmanned systems operate as a unified force. Helicopters could act as mobile command hubs, coordinating drone swarms, directing ground forces, and processing battlefield intelligence faster than conventional methods allow. And as these systems are refined, lessons learned in the field could accelerate innovation across civilian sectors. Precision manufacturing, advanced AI navigation, Battery and fuel efficiency breakthroughs and materials research have dual-use potential, from disaster relief and transport logistics to renewable energy solutions. Military innovation becomes a catalyst for broader societal advancement. Every successful test flight, every autonomous mission completed, every tactical exercise executed not only validates engineering, but builds momentum. Pilots gain confidence in their machines, engineers refine systems with real-world feedback, and the continent begins to envision a new era of self-sufficient, technologically advanced military capability. Africa's air power may never be measured solely in numbers of helicopters or missiles. It will be measured in agility, innovation, strategic independence, and the ability to project influence intelligently. Maxwell Chikumbutso's vision, though ambitious, hints at the possibility of an African aerospace renaissance where imagination, engineering, and determination converge in the skies above. And when the first fully operational squadron takes to the skies, the message will be undeniable. The age of externally dependent military aviation in Africa is giving way to a new chapter, written with indigenous expertise, bold ambition, and the rotor blades of innovation slicing through the horizon. As the helicopters ascend over sprawling landscapes, deserts, forests, rivers, and mountains, their presence begins to reshape not just military calculations, but the very psychology of conflict. Adversaries once confident in their superiority now have to account for an agile, adaptive, and intelligent aerial force capable of rapid response, precision strikes, and real-time situational awareness. The mere possibility of encountering such advanced aircraft forces strategic planners to reconsider conventional approaches. Imagine a cross-border operation in a complex terrain. Insurgent movements are tracked by integrated surveillance drones, their locations relayed instantly to manned helicopters acting as airborne command centers. AI systems process thousands of data points in seconds, terrain analysis, wind conditions, thermal readings, threat assessments, allowing pilots to make decisions that are faster, more precise, and safer. Troop deployment, supply drops, and reconnaissance missions unfold in seamless coordination, almost like a single living organism reacting to a dynamic environment. These helicopters also redefine asymmetric warfare. Small, agile units equipped with these aircraft can project power far beyond their size, leveraging speed, intelligence, and adaptability to counter larger, slower forces. Traditional metrics of air superiority, numbers of aircraft, tonnage of firepower, lose relevance. Instead, efficiency, survivability, and networked intelligence determine battlefield dominance. But this isn't limited to combat. Humanitarian and disaster response scenarios illustrate another dimension of strategic utility. Floods, wildfires, and remote medical emergencies become manageable with helicopters capable of rapid deployment, autonomous supply drops, and aerial coordination. What was once an impossible logistical challenge now becomes routine, showcasing the dual-use potential of advanced aerospace technology. At the heart of this transformation is the technological ecosystem surrounding the aircraft. Engineers, programmers, and pilots form an interconnected network of expertise, constantly iterating on design, software, and mission tactics. Training programs evolve in parallel, incorporating AI-assisted simulations, virtual reality tactical scenarios, and predictive maintenance protocols. Every sortie becomes both an operational mission and a live data-gathering opportunity to refine systems and procedures. The ripple effects extend to geopolitics. As African nations demonstrate indigenous aerial capabilities, alliances shift. Nations that once dominated African defense markets now find themselves negotiating with an emerging force of technologically competent neighbors. Regional collaboration becomes more viable as shared standards for aircraft, avionics, and maintenance reduce operational friction and encourage joint exercises. Africa slowly moves from being a consumer of military hardware to a developer, producer, and innovator. Even within the global defense community, attention shifts. Analysts dissect flight data, AI algorithms, and design innovations. Competitors consider partnerships or counter-development. But the defining factor is no longer simply access to funding or foreign technology. It is homegrown capability, local expertise, and operational adaptability. And then there is the psychological dimension for the continent itself. Confidence in indigenous innovation sparks inspiration in young engineers, pilots, and scientists. Universities, research centers, and startups are invigorated by tangible proof that complex aerospace systems can be conceived, developed, and deployed locally. The helicopter becomes more than a machine. It is a symbol of what African ingenuity can achieve when vision meets determination. The first live combat simulations reveal even more. Teams coordinate air-ground operations flawlessly, drones relay high-resolution imaging to command nodes, and advanced AI predicts enemy movements before they happen. Rotors slice through morning haze, the sun glinting off composite fuselages as the fleet executes maneuvers that once seemed impossible. Observers, military officials, engineers, international analysts watch in stunned silence, realizing that a new chapter of African strategic capability is unfolding. Maintenance, often the Achilles heel of imported systems, is now integrated into the design philosophy. Smart diagnostics, modular parts, and predictive AI reduce downtime drastically. Remote bases in deserts or dense forests can sustain operations without waiting weeks for foreign contractors or spare shipments. Operational independence becomes a tangible reality. And as these capabilities mature, doctrine evolves. African air forces begin to envision networked warfare, manned helicopters coordinating autonomous drones, secure satellite communications feeding battlefield intelligence, and AI systems optimizing response times and resource allocation. Future conflicts will no longer rely solely on brute force, but on speed, intelligence, and precision. Maxwell Chikumbutso's vision, if realized, does more than elevate air power. It catalyzes a strategic shift. Africa becomes a hub for aerospace innovation, a center for advanced training, and a proving ground for technologies that could influence both military and civilian aviation globally. Every flight, every exercise, and every successful mission strengthens the narrative. Africa can innovate, lead, and redefine what is possible in aerospace. And as the sun sets over distant savannas and cityscapes, the helicopters continue their patrols, their rotors a steady reminder that the skies above Africa are no longer empty. They are alive with the promise of a continent reclaiming its technological destiny, one flight at a time. And finally, as these helicopters return to their bases after rigorous sorties, the vision becomes undeniable. Africa is no longer a passive observer in the skies. It is an innovator, a strategist, and a force to be reckoned with. What began as ambition has evolved into tangible capability, rotors slicing through the air, AI systems guiding precise maneuvers, and pilots commanding machines that redefine what is possible. Maxwell Chikumbutso's revolutionary war helicopters are more than just machines of war. They are symbols of technological sovereignty, ingenuity, and continental pride. They represent a future where Africa designs, builds, and controls its destiny in the air, projecting power, protecting its people, and inspiring generations of innovators to come. The skies above Africa have changed forever, and with each flight, the continent takes one bold step closer to claiming its place among the world's aerospace leaders. The age of reliance is over. The era of African ingenuity has arrived.